Today, my name is Steven Wang. So today I will cover MongoDB disk size management. So basically, today my talk is how to reduce MongoDB disk size. So first of all, I will introduce MongoDB cluster architecture, and then advantage of disk size, smaller size. And then here, I will show like a 4 user cases here. The next step will be like a reclaim disk space. So here, this is the typical MongoDB cluster architecture. So we have MongoS deployed on app servers, and also we have 3 configured servers contains metadata. All the Mongo data is stored in Mongo shard. So we can deploy multiple Mongo shards here. So for each Mongo shard in our current environments, we have mix. So most of them are like has 1 primary, 2 secondaries. So basically, the web traffic will hit MongoS. MongoS will work as a router, and then write data to all the shards. So here, the topic is to reduce disk size. So if we have less disk size, okay, so that means more data can be fit into memory. So it can speed up our query. And smaller data means smaller index. So it's, if your index size is smaller, your query can be faster. So the next one is about like cost saving. So here, first one, I will, use the first case like migrate to wiredTiger. If you still using mmap storage engine, so we better to migrate to wiredTiger. wiredTiger is like a document level concurrency control. It has a better writing performance than mmap. So also wiredTiger support compression. So here, this screenshot, give us like a comparison between mmap and wiredTiger. These 3 columns show the wiredTiger with no compression, snappy compression, and Z-lib compression. You can tell from this screenshot the size reduced dramatically after you use MongoDB, use wiredTiger storage with compression. So here you can see is 15% of the original size. So for wiredTiger, if because it will use like more CPU to compress and decompress data from disk to memory, basically your load will increase. So this is the compression between wiredTiger and mmap. So for writing performance, wiredTiger use document level, this is collection level. So for compression, wiredTiger support compression, mmap does not. So here, before we do migration, we need to think about something. First is always test your migration procedure in your staging environment or test environment. So the second part is very important. We need to check like the priority for your replica set, because sometimes in order to fail over, when you do if.conf, it's the priority number may be different. So better before you do the migration, you set up the same value so you can easily to fail over. This part is basically think about it from application part. So, for our case, we use 2 secondaries, and then we put our read traffic point to the secondaries. So we set like a read in our application part, we set a read preference mode to secondary preferred. So when we do the migration to Windows failover, because when we migrate, we do the migration on secondary first, it will cause like timeout. So before we do the migration, we better change it back to primary preferred. After that, you can switch back. So we do meet this kind of scenario, during the migration. If you don't switch back, it will cause a lot of issues. So the next part is about we need to check, make sure MongoDB balancer is off before migration, and then check hardware like disk size, memory size. Memory is basically use the size to configure your wiredTiger cache size GB in the MongoDB conf. So CPU, because wiredTiger will use a little bit more CPU than mmap, so better check your CPU usage. So during the migration, we use several tools to monitor the performance. One, we use the MS, and the other one, we use New Relic to monitor the application response time and error rate. So if that something happen, we can know, if it's because of the migration or something else, we can find out and then do the next step. So always tell Mongo logs during the migration. So MongoDB log give you a lot of information. It will tell you, okay, that the data copy process, index building process, etc. Is all the information is in Mongo log. Tell Mongo log give you more information, give you the the process, Mongo internal working. Okay. So next part, send out email, the migration, let everybody know you are doing something. So after migration, we better monitor all the clusters for a while. So this is the Mongo wiredTiger migration procedure. So here basically, on app server, we need basically here we use the Puppet to run the migration. We configure the Puppet master, and then on MongoS and Mongo config server and shard, we run the Puppet agent to get migration done. The idea behind is, here on the application server, if you run Tomcat or Apache or Index, it doesn't matter. So you first stop your application service like a Tomcat, and then stop a MongoS service. And after you migrate, apply the new Mongo patch with the wiredTiger configuration, with the wiredTiger ending storage. So you can start MongoDB, start MongoS first, and then start your Mongo Tomcat. Then you can tell the Tomcat log, see if something happened. So this is the procedure to first migrate all the MongoS servers, and then we come here to migrate the configuration servers. For the sharding, for the replicators, first one we migrate one secondary, and then we run the migration process on the second secondary. Then do the failover, run migration on primary. So basically, this is the procedure on the official document from Mongo website. It's very clear. So the last step is the enable balancer. During the whole process, we just monitor everything, New Relic, MS, and the application MongoDB log, so we can tell what happened. So this is the compression ratio after migration. Here we use a Snappy compressor. So I choose 5 cluster here. Before it's 2.8 mmap, and this version after 3.0. So the size before, size after. So we can see the compression ratio is really, really big. So we can see here from like 1 terabyte dropped to 100 gigabytes. So the wiredTiger, really give us a lot of space. So here you can see the number is different. It's because different file we stored. So different files have different compression ratio. Okay, the second part is about set TTL index. If you plan ahead, you can, when you create a collection, if your data, you don't want to keep like all the history, you only want to keep 1 year or 90 days data. So you can set up a TTL index on some field. It will run background thread, automatically delete all the old files here. So here the requirement you need to have like a data field, have like a data type object. So if your collection does not have, we can have other ways to purge the data. So there are two ways. One way is you can specify document after 13 times seconds. Here, if you are one example, if you want to buy in 90 days, so you can put like you buy after seconds, like this 90 days, this seconds. Okay, the unit is seconds. And also you can buy document in the future. So here you can create like an index here and put like the future data. So when the data hit to this date, this record will be deleted. So basically the requirement here, if your company don't want to keep a long time data, so you can use TTL index, or you can archive the old data first, and then you let TTL run the delete process on the background. So some note from TTL index. So TTL index is like there is a background task run every 60 seconds. And here TTL does not support compiler index does not support TTL, and the default RD field does not support TTL index. So although RD field has like a timestamp, hidden timestamp, it does not support TTL index. So if you already created TTL index, you cannot, it's hard to change. You better, either use this way or drop the index and then recreate it. So this some limitation here. Okay. So the next case is about we write a procedure script to use the RD field to purge the data. So if your collection does not have a timestamp field, here we can use the RD field. I got this search online, from this website. You can put your time here, like I put 2017, January 25th. So here it will give you object ID. So here, the object ID, I run the object ID here from Mongo command line. So dot get timestamp, I can get the exact same time here. So basically the idea, you can use this way to the hidden timestamp to remove old data. So this is like a very simple script. So here you can get all the ID less than the timestamp here, and then you run batch. You can like 3,000, 5,000. So you can change this value. Really, you want to test that, run that first and test, see if it's called the issue, and then you can remove batch by batch. So this is another script, loop script to purge the data. So the next one, we meet an issue. The issue is we have some data is already run 5 years. So it takes a long time. If we use the batch script to purge that, it takes a very long time. So the way here we use one way. Here it's use replicator idea. So we took one secondary out to the replicator and disable the replicator properties and set as standalone server. Here, then we create a new collection, like a sample log new. Then we, from the previous collection, and get all the 3-month data inserted to this new collections. Then we use rename method, rename name, and switch that. After that, we can create like a TTL index on that, because we want to by that. So here I didn't put include here, and then you can stop this Mongo standalone MongoD on the server, and then you can enable replication and start the MongoD. It will automatically add back to the replicator thread because it has local uplog position. It will get synchronize the uplog from the primary. It will, but this set has 3-month data. This has 5 years data. So we can do the same thing for the secondary C, and then do the failover to run the same thing. This is one way to do the C and A. Another way is we can always stop MongoD from the secondary C and wipe all the data, and then restart MongoD, because default the data copying will copy from secondary, not from primary. So we can easily build this one from here. So after we have 2 copies of 3-month data, so we can fill over this one to other for either one, and then we can run the same thing to purge the data. So use this way, we reduce the time. Before, 5 years data is taking me, according to calculation, a couple years. Now we can run this process in couple days to get the thing done. So for this case, it's all based on we can purge the data. We don't need to keep all the history data. So Mongo itself won't reclaim the deleted space. So we need to run some process to get all the space back. So there are a couple ways to do that. The first way is compact, is work on the collection level. So this is the command. The next one is repair database. This work on the database level. But for these two methods, they both require downtime. So, and also for this one, it's need your free space need have 2 times of your user space plus additional 2 gigabytes. So we use the third one. The third one is the idea is like before, we can shut down one secondary and stop the MongoD from one secondary, delete all the data from the data directory, and start MongoD instance. So replicator will review the data, copy all the data from another secondary, and rebuild all the index. So it will it will rebuild the new data. So it can reclaim the this space. So for primary, do the failover, run the same procedure like secondary. So we can get all the space back. So summary, if you can use wiredTiger, you use wiredTiger, and then for different scenario, you can purge the data, set up a TTL index, or you can use the RD field to purge your data, or use replica set to resync your data to get a faster purge. So the last thing is always remember to claim the deleted space, because MongoD won't do that by itself. Okay, thank you. Any questions? Okay, thank you.